pH and POH. You've probably heard of pH before. Not sure that you would have heard of POH, before this point in time. So what that stands for, this guy Soren Sorensen, I know his dad and mom must have been really creative with coming up with his first name, or they really, really liked the last name so much that they had to double it up. At any rate, Soren Sorensen came up with this idea, and it means the power of the hydrogen ion. Sometimes people will say parts hydrogen. There's a couple of different things, but the original term was power of the hydrogen ion. Because remember, it's this hydrogen ion that we're moving back and forth. Yesterday, when you saw the lecture in class and discussion with that, what you were looking for was, where did the hydrogen go? Which one of them had more hydrogen? Okay, so it's that idea, all right? So if you know, and remember these square brackets mean molarity. That's the concentration. If you know the hydrogen concentration or the hydroxide concentration, you can actually determine the pH, okay? pH is going to equal the negative log of the hydrogen concentration, or sometimes they'll have it as hydronium. These terms, this hydrogen and hydronium, they're used interchangeably. They mean the exact same thing. And then if you know the pH, you can determine the hydrogen or hydroxide concentration by taking 10 to the negative pH. So you should have the first 3 lines of your note packet filled out when you're done with this slide. Good? Okay. The pH range for water solutions is 0 to 14. Your pH for acidic solutions, the pH is going to be less than 7. For basic, it's greater than 7. And for a neutral situation, it's going to be equal to 7. Biological neutrality is generally accepted as 6 to 8. So in biology, they kind of give you a bigger range for this. But in here, it's 7. So if you've heard that it's between 6 and 8, that's why, because you've been exposed to that biology world. And here we're a little tighter with our definitions. Right? One more time. You get this down? Okay. So the way this works is that the concentration of our hydrogen ions compared to the distilled water, like at 0 here, 7 is pure water, and then we go up. And then here we're going to go down. Battery acid is very acidic. All right, so POH measures the concentration of the hydroxide ion, And the POH is going to equal negative log of the OH minus. pH plus POH is going to equal 14. So if you know pH, you just subtract that from 14, and that's going to give you your POH. Okay. Also, H plus times the concentration of the hydrogen ion times the concentration of the hydroxide ion equals 1 times 10 to the negative 14. So if you know one of these, you can divide this by the other and get the other value. That makes sense? Or you can figure out the pH or POH and go backwards that way too. There's a couple different ways you can play with that one. All right, so strong acids and strong bases. They wanted you to list this, so I'll give you a second to write these down. Okay. Okay. So there is a difference between a strong acid and a strong base and a concentrated acid or base. Okay. A strong acid and base can be dilute enough that it doesn't hurt you. Okay. And a weak acid or base can be concentrated enough to where it does hurt you. So just keep that in mind. There's a difference between that. The idea behind these being strong acids or strong bases is that they're going to ionize completely in water. So what does that mean? That means that if I put hydrochloric acid, I put that in water, okay, this hydrogen is going to be, it's going to form H3O plus the Cl minus ion. Almost all of this is going to break apart into these two things. Okay, that's what it means to be a strong acid. It's going to completely ionize. It's going to completely turn into ions. Now, a weak acid, so if we had, let's say, well, hydrogen fluoride, I guess, is an easy one to do. Okay, hydrogen fluoride plus water. your arrow is going to look like this because it's going to go back and forth between the two. It's going to be a reversible reaction. And a lot of times you'll see it when you actually draw it. People will draw it like this. It's faster. It's going to break down into your H3O plus your F minus. But some of this is going to then turn back into this. And some of this is going to turn back into that. And you change it back and forth and back and forth. Here, it's just going to stay apart in these ions. Now, that doesn't mean that this stuff isn't going to kill you, because it does. This is deadly, okay? So just because it's called a weak acid doesn't mean that it can't hurt you, because it can. Just like hydrochloric, I could dilute that down enough to the point where I could drink it and be fine. Even though it's a strong acid, if it's very, very, very dilute, I'm okay with it. All right? In fact, your stomach has this acid in it all the time. But your stomach also has a mucus lining in it that prevents this acid from eating your stomach up. Sometimes that happens, though. You'll get something called an ulcer, okay? And that's where the acid, the mucus isn't where it needs to be, or enough of it there, and it'll start eating holes in your stomach. That's called an ulcer. You can also get esophageal ulcers, where if you have like burp a lot and you get that acid, if you've ever tasted that sour kind of taste in your mouth, like after you burped, that's your acid coming up, okay? And if you do that a lot, okay, then they call it gastroesophageal reflux disease. So they abbreviate it GERD, okay? And it can actually give you esophageal ulcers. People who are bulimic that throw up a lot because they're bulimic, that acid will also start to eat away at their teeth, and they'll get a lot of cavities and rotten teeth and stuff from it too. This hydrochloric acid vaporizes and forms when people smoke meth. And that's why, like, if you've seen the meth addicts that look like they've aged like 50 years in a year, it's because they're bathing their face in hydrochloric vapor. Measuring pH, we can do that in a couple different ways. We can use a pH meter. That's going to measure your hydrogen ion concentration. We'll be using that next week. It's going to give an electrical signal, which then you can see on the computer. We also use a universal indicator, which is a variety of different chemicals in there that will give you an indication of a color change. And then we can also use litmus paper, which shows color change. So for litmus paper, the blue paper in the presence of a base will stay blue. In the presence of an acid, it turns red. So blue base, acid, red. So the red will stay red, the blue will turn red if you've got an acid. If you've got a base, the blue will stay blue and the red will turn blue in the presence of a base. If it's neutral, then neither one of them change. They just stay the same. And if we go back up here, your universal indicator works very similar to these colors here. So in the presence of like a really strong acid, it's going to be red, and then it kind of goes through this color change to get to your base. So here's the pH. That's what I was talking about with the pH paper. And then here's your litmus paper. It'll turn blue in the presence of a base. Blue litmus paper turns red. And it's almost more of a pink than that, but that's the idea. All right. So we're going to figure out the pH of this molarity. So what you need to do is you need to take this molarity, take the negative log of this value, and that will equal your pH. So get that done on your calculator. Make sure you know how to use your calculator because this is what you're going to be doing tonight for homework. All right, you get 1.63. Ah, shoot. 1.63. So now we're going to figure out the pOH of this guy. So we have the molarity here. We want to figure out the pOH. So take the negative log of this guy to figure out the pOH. Let me see, I got 2.19. No?
No. I got negative 0.81.
You should have gotten,
I don't know.
so type in the negative sign and then hit your log button. Type in the 6.50, and then on that calculator, you're going to hit the second button and then that button right above the 7, which says EE, and type in -3, and then hit equals.
Yeah, I got it now. I didn't do the -3.
So 2.19 is the answer that you should have gotten for this guy. Now, what if this is the pOH, what is my pH for this? It's not on your paper to ask that question, but I'm going to ask it. What's my pOH of this guy, or my pH of this guy? How would I find that? pH plus pOH equals what? 14. So if I know pOH is 2.19, how am I going to find out pH? Yep, so 14 minus 2.19, I end up with 11.8. The pH is 11.81 for the pH. What if I wanted to find out the hydrogen concentration? How would I figure out the hydrogen concentration for this guy? I can do it 2 different ways. Way number 1, which I think is faster, is I can take the negative 10 to the negative this guy, and that's going to give me the hydrogen concentration. Or I can take 1 times 10 to the negative 14th and divide it by this guy. There's a couple of different ways I can approach that. All right, if we wanted to figure out the hydrogen and the hydroxide concentration, I've got a pH of 3. I'm going to take 10 to the negative 3, and that's going to equal my hydroxide concentration. And your the 10 to the x is the second log. So if you see log on your calculator, if you hit second and then log, that'll give you the 10 to the, and then you have to type in -3. And it's molar, so it's a capital M for your value. approach this two different ways to figure out the molarity of the hydroxide concentration. I can take this guy and find the POH, which would be 11. And then I can do 10 to the negative 11 to get my hydroxide concentration. Or the other thing I can do is I can take this guy and I can take 1 times 10 to the negative 14 and divide it by that. So either way, I should get my hydroxide concentration should equal 1 times 10 to the negative 11, and that's going to be molar. So there's a couple of different ways you can get these to manipulate it to get what you want. Anybody not able to get those? They need help, don't know how to work your calculator, anything.
Whenever I put negative exponents in my calculator, it just says error.
That's because you're using the minus key and not the negative.
Okay.
So the negative key is down here.
Oh, yeah. Okay.
And the minus key is up here. So make sure you're using the negative.
What was the formula for like both of those?
So to find out the POH here, I did, so I'm going to just switch this slide so I have more room to write, okay? So pH plus POH equals 14. So I knew the pH was 3, so I could figure out that this was 11. Does that make sense? Okay. So then if I want to get my hydrogen concentration, that's going to be equal to either, and I can do this either way, 10 to the negative pH, or that would equal 1 times 10 to the minus 14 over the hydroxide concentration. Likewise, my hydroxide concentration would equal 10 to the negative POH, which equals 1 times 10 to the minus 14 over my hydroxide or my hydronium concentration. Wow, I'm getting those messed up today. Sorry. So there's a couple of different ways to approach this, depending on how you want to do it. I think it's easier to do 10 to the negative whatever because it's less keystrokes. I'm just lazy that way. The other thing that you can do is you can, if you have one of these nicer TI calculators, you can store this value in as one of your letters on your calculator, and then you don't have to type it in all the time. So I have mine as W because this equals what's called KW. We talked about that yesterday. So, but if you just want to store that in your calculator, then you don't have to type that guy in as much. So, all right. So today what you're going to do is you were supposed to do 18.1 yesterday. So if you have that done and you want me to double check that, make sure that it looks good for you. You can bring that up to me and let me double check it and then you're working on 18.2 today. So I'm trying to go through and get your molarity pivot labs graded today and in the computer. I also have some work that I need to hand back to you, but this is all we're doing today for notes. Okay. I also have over on the sideboard the schedule for the rest of the year. So if you're interested in seeing what's going on for the rest of the year, that's available too.